Hello, everyone. Happy February 13th, and thank you for joining our webinar today called Fixing Hallucinations in RAG Systems. We're excited to be joined by two folks, one from Galileo, our head of product, and Roy, who I'll introduce in a second, but wanted to quickly take just a few minutes to do some quick housekeeping. So we expect to take the full hour today. There is a Q&A button at the bottom of your webinar window. That is where we will be taking questions today. So if you have any questions, please drop those in there and upvote. There's also an upvote feature if you want to upvote the questions that you would like to be promoted towards the end of the call. During the last 10 to 15 minutes of the call, we'll have time for live Q&A. So again, please ask your questions throughout. We'll be answering them as we can, and then we'll have time at the end for questions. But without further ado, I wanted to quickly run through today's agenda. So I'm Usman Javed, I lead marketing here at Galileo. And the agenda today will be doing a quick introduction of Galileo. Then Roy from Pinecone will be giving us a little bit of a 101 on all things RAG. He'll be giving a quick recap on embeddings. We'll be reviewing what is a vector database and getting an overview of Pinecone. Then we'll be switching it over to talk about Retrieval-Augmented Generation. What is this wonderful methodology that everybody has kind of gravitated towards this last year, the last 6 months? We'll be going through what is RAG, its key components, some of the challenges that teams run into, and then giving an overview of how you can actually evaluate RAG with Galileo and our solution. At that point, Kike will go through a demo and we'll have some time for Q&A. So with that, I'll turn it over. Actually, before doing that, wanted to also quickly highlight an event that we're hosting at Galileo called GenAI Productionize. It's taking place on March 13th, and it's really meant to help teams understand from leading speakers, researchers, and builders on how they can actually productionize their GenAI systems. We believe 2024 will be the year where the enterprise adopts GenAI in a meaningful way and goes from POV to production. So we hope you'll join us, and that site is live, and we'll drop the link in the notes as well. But with that, I'll turn it over to our speakers, Roy and Kike, to introduce themselves and take us away. Thanks, folks.
Hi, everyone. I'm Kike. I'm the head of product at Galileo, and super excited to share some of what we've been working on with you today.
Hi, everybody. I'm Mauricio Abercoin. I'm a staff developer advocate at Pinecone. Also very excited for this webinar. I'm excited about what Kike is about to show, and happy to talk to everybody about embeddings and RAG.
Awesome. Before we begin, let's take a step back and set some context about why fixing hallucinations in RAG system matters so much and why we're here today. In 2023, GenAI caught us all by surprise. Every company out there was rushing to see how they could leverage GenAI to better serve their users and stay competitive. However, what we saw was that most of the use cases never made it to production back in 2023. There were prototypes or internal use cases and never made it to the light of day. But 2024 has come, and that is changing. We've seen an immense urgency from companies in getting the systems to production. It's probably why we have so many people in this call today. The second trend we're seeing is that RAG is proving to be the winning strategy to productionize LLM applications. And the reasons for this are obvious, and we're going to go through them later today. But in short, RAG allows users to leverage externally trained LLMs on your own data without having to fine-tune your own model. It's a very easy, quick, and cheap way of building really good and powerful applications. Now, what we see is that most users still lack a way of building trust and confidence in the quality of their systems. Products are getting stuck in that prototype phase because teams and companies lack a way to prove to themselves and others that the application is working the way it's supposed to. And that's why we strongly believe that without a trust in an evaluation layer, the stack is incomplete. Teams and companies need to build that confidence in their applications working well, and confidence in that the version of their system that they're putting out there in the real world is the best version they've got. And this is where Galileo comes in. Galileo is an evaluation and observability platform that helps teams and companies build that trust in their generative AI applications. In pre-production, Galileo Evaluate helps them answer the questions of how well is my system working, as well as the question of if I change this one thing, am I making things better or worse? And once productionized, Galileo Observe helps them make sure that the quality of the system in production is what they were expecting, that the model is behaving the way it's supposed to, and that queries coming from users match what the system was designed to handle. In a few minutes, I'm going to show you how to do those things for RAG applications using Galileo. But first, Roy will walk you through how vector stores work and how to build RAG applications.
Thanks, Kike. So I wanted to start today by talking about the basics, talking about embeddings, because they're basically the cornerstone of everything that we do when we talk about RAG applications. Can we go to the next slide, please? So let's start with definitions. Embeddings are essentially the internal representations of a neural net that has been trained on a whole bunch of data. And basically what they do is represent they're the internal representation, right, of relationships and features of objects like words, documents, and images. But they're represented in what we call a continuous vector space. So basically what that means in simple terms is we have two objects, they have some relationship to one another, and we're able to represent that relationship between them in the form of a vector, in the form of a set of vectors. And we do that using the embedding model, which is essentially the same models that we use for language generation, but basically used a little bit differently to extract those numerical representations. Can we go to the next slide? So to understand what that looks like, I've created this very, very simple visualization. Of course, this is not what embeddings actually look like if you try to represent them faithfully. But in a simplified way, we can imagine that if we have a set of terms that have some sort of semantic similarity between them, they will be represented in the vector space as being close to one another, right? So in here we have the days of the week represented in yellow, and their embeddings are clustered together because their semantic similarity is high. Let's keep on going. So beyond being able to represent particular words, embedding models are able to understand the contextual meaning of words within a bigger context. So for example, here we have 3 sentences that all use the word bank, but the meaning of the word bank is drastically different between them. And so their representations in the embedding space are going to represent that semantic difference. And then conversely, in the bottom 2 sentences, we have the use of completely different surface forms, but because the meaning of the sentence as a whole is similar, the representation in the embedding space is going to be close together. So these are what embeddings are very quickly. Let's move on to the next slide. And let's talk a little bit about vector databases, because once we have these embeddings, we have these representations, we're going to need to be able to store these representations somewhere and have some sort of mechanism to query them effectively. And that's what vector databases are for. They allow us to manage vectors like embeddings at scale, and to interact with them as if we were interacting with any other database. So all of your normal operations like inserting, updating, deleting them, those are the things that vector databases do at scale without having you kind of like think about the memory constraints that you would otherwise have to think about if you were to use, for example, a vector index like FICE. The main function of a vector database is to allow us to efficiently query vectors from a huge collection of vectors based on some similarity metric. And there are several similarity metrics that you could use depending on your use case and depending on where those embeddings were, how those embeddings were created in the first place. The last thing that a vector database allows us to do, which is incredibly important, particularly for RAG, is to associate specific metadata with each vector that we upsert into the database. And we'll see how that comes into play further down the line when we talk about RAG. Okay, let's move on. Pinecone is a highly performant vector database. It's a distributed vector database that can automatically scale to handle potentially billions of vectors while maintaining a very low latency query. And of course, it is optimized behind the scenes so that you don't have to worry about performance or cost, even when you're handling vectors at a very, very high scale. All right, let's move on. Okay, so now let's talk about retrieval-augmented generation. So hopefully you're not foreign to these two concepts that I talked about before, but for those of you who weren't, we kind of level set, and now we're ready to talk about RAG. Let's move on. A lot of people talk about hallucinations in LLMs as sort of a bug. But this tweet from Andrej Karpathy is one that I really think represents the reality more faithfully. And that is that LLMs don't actually hallucinate sometimes, they always hallucinate. In fact, we have no assurance that any of their responses has anything to do with factual data or with any data at all. They're essentially just dreaming, right? We can sort of guide the way that they dream in certain ways by using prompts, but we don't have any kind of assurance that like the response is going to be correct. And so to put it succinctly, it's not a bug, right? That's literally what the LLM is supposed to be doing. And so that kind of requires us to think about how we use the LLM in a way that is not going to be problematic or introduce kind of like lack of trust for our application. And that's exactly where RAG comes into the picture. Let's move on to the next slide. So as I said, LLMs don't know anything about our data. And I emphasize the word our data because, of course, like different people are and companies are concerned with different parts of the world and different areas that they are specialized to deal with. And we can't expect the LLM to actually have the knowledge that we need in order to fulfill what our customers are expecting. And so we can think about the LLMs, instead of being the source of truth, being sort of a reasoning engine and a natural language interface that will wrap the information that we are able to provide it such that our users can get a response that is pleasant to read, that is easy to understand. And what we're going to do is actually create a knowledge base that will leverage the user's prompt to then retrieve content from that knowledge base that we consider to be relevant. And then we'll take that contextually relevant knowledge and we'll inject it into the context window of the LLM so that it can then give us a nice response. Now, the context window, right, this amount of information that we can pass on to the LLM as part of our prompt is very limited. And let's double click on that because the immediate kind of like thought that people have is, okay, so I'm going to take all of the documents that I have in my organization and I'm just going to stuff them in the context window and everything will be fine. But unfortunately, as we saw in the Lost in the Middle paper, the behavior of LLMs is such that they pay a lot more attention to the content that they receive at the very beginning of the context. And as the context continues, their ability to recall the correct answer from that context is reduced. Only there's a slight uptick in the very end, but as a rule of thumb, you have this U shape that kind of indicates that the effective area of the context is at its very beginning. So even if we have a very, very long context, we still don't have the assurance that that the LLM will actually be able to construct a faithful answer to that context if it is too long for it to actually do it accurately. Okay, let's go on to the next slide. This is another kind of demonstration, specifically with the Claude 2.0 or 200K context window, using a test called Needle in the Haystack, where you can see that basically the answers, we're hiding the answer somewhere in the context, and we're trying to see whether or not the LLM is able to retrieve that answer from different parts of the context. And as you can see here, it's very clear that the most effective and reliable area of the context is the very beginning. And as you move on forward down, the accuracy of retrieval goes down drastically. And so that is like one huge reason why you want to be able to actually limit the size of the information, the data that you're going to send to the context window of the LLM as part of your RAG application. So that kind of gives us the motivation for why we would want to use a specialized sort of database to retrieve semantically relevant content that is going to be very focused and accurate. Let's move on to the next slide. So where we start in this process is we're going to have a prompt that is going to be kind of semantically ambiguous. And that's why we can't just take that prompt and go directly to, say, for example, do a SQL query or do a graph database query, because we have to still get through to the user's actual meaning. And that's where embeddings come into play again. We can use embedding models to extract that semantic meaning, and then use that embedding to grab our information back from our embedded knowledge base, and we'll see how that process flows in a second, to basically grab the semantically relevant content and inject it into the prompt in a very focused fashion. Let's move on to the next one. So this is basically the ingestion part of a RAG application. We start with some form of data source. We go through a process of chunking where we're basically saying we're not going to take the entire document that exists in our data store and then embed it, but we're rather going to break it down into smaller parts so that when we do a search, we hit those smaller parts, and that basically can increase the accuracy of our system overall. Once we've created these chunks, we embed them. And using the Pinecone API, we can take those embeddings and upsert them into the database. In conjunction with the embeddings themselves, we have the opportunity to also associate these embeddings with the metadata that is interesting to us. So for example, if we have a set of chunks and those chunks come from a document, you can imagine a document, the metadata having some representation of the original document from where the chunk came as some form of ID or potentially a URL or any kind of other reference data, so that we can use that later on as reference when we construct our response. Okay, let's move on to the next slide. And this is the application side of a RAG application, where again, our process starts with taking the user's query and embedding it. We can leverage metadata filters to reduce the search space for our query, but we send that embedding through the API to the vector database. We now get back semantically relevant results, including the metadata that they are associated with. And then we can take those results and then stuff them in the context window. And now our LLM is going to be ready to provide us with a contextually relevant response based on this context. And then we can stream it back into our application. And that is basically the whole architecture for a RAG application. Of course, if you have questions, please feel free to put them in the Q&A section, and we'll answer some of them at the end of the webinar. And here, I'll kick it off back to Kike.
Thanks, Roy. Okay, so now that we've learned about how a RAG system works and how it gets built, let's talk about how you can evaluate your RAG system and improve it. Now, if you remember from a few slides ago, there's two sides to building a RAG application: the ingestion or the setup needed to build that vector store, and the application side. There's a number of things that can go wrong on either of these sides that would lead to poor quality or hallucinations. You might be missing data, you might be chunking them in the wrong way, you might be using an embedding model that isn't optimal. Maybe your retrieval strategy needs to change, or your prompt or the model you're using. And today, most developers don't really have a good way to measure how well their application is behaving, let alone diagnose where in that workflow of things is something going south. And this is where Galileo, RAG, and agent analytics comes in. Galileo is designed to help you measure, debug, and optimize your application across the dev cycle. It helps you answer the questions of what is the quality of my system, where are things breaking down, and how can I make things better? So the first question a developer would ask themselves is, how well is my system working? One of the key pillars of Galileo are our guardrail metrics. These are metrics that we've developed in-house geared towards helping you answer that question. Half of the team at Galileo is actually researchers working on these questions. And for RAG metrics, we just announced a suite of metrics to help you assess the quality of your system. These are context adherence, completeness, attribution, and utilization. If I was developing a RAG system, I would use context adherence and completeness as my North Star metrics. Context adherence detects whether your model's response is adhering to the information available in the context. Low adherence means the model is making things up or stating facts that were not there in that context window. Low adherence helps me identify those hallucinations. I personally think of context adherence as my precision metric, whereas completeness is my recall metric. Completeness measures measures how much of the information in the context that was pertinent to the question was included in the response. Here, for example, the question was, what is the capital of France and when did it become the capital? And the response was, the capital is Paris, France. Now, the context included the fact that Paris is the capital, as well as in that first paragraph, as well as when it became the capital in that last paragraph. Because all the facts stated in the response are accurate according to the context, context adherence is high or 100%. But because the question asked for two things, both of which were in that context window, and the response only included one, completeness is low or about 50% because some things were missing. The two together, these two metrics, can give me a sense for how well my system is working. Today, these metrics are computed via chain poll, a prompting technique developed in-house that combines chain of thought prompting with majority voting. And we've seen pretty great results from doing this. Now, the next question a developer would ask itself is, okay, now that I know how my system is doing, let's go one level deeper, and how do I debug this? To help with this, we've added trace visualizations. This is the ability to track step by step what went down in your experiment executions. Visualizations helps you diagnose where in that sequence of steps that were taken between the user's query and the model's response did things go wrong. It might seem pretty simple, but this is actually really powerful. And we actually don't stop there. In my opinion, one of the coolest things about Galileo is that we don't just help you evaluate end-to-end systems, but also help you identify where in that sequence of steps did things go wrong. And our guardrail metrics that we were just talking about can be applied at the step level. So you don't just see the steps, but you can evaluate each step independently. And this can help you identify where things went wrong. Two of the metrics that we just launched as part of our RAG and agents analytics product are called chunk contribution and chunk utilization. And these are metrics that can be applied to your retriever steps and help you optimize that retriever step. Chunk contribution detects whether a chunk or a document retrieved was actually used by the model to generate the response. At an individual level, it helps you see where the information is coming from, jump-starting that debugging process. And when looked in aggregate, chunk attribution helps you optimize your retrieval logic. Retrieving too many documents that are not used, as we saw from Roy's presentation, decreases the quality of your system, and actually also increases cost, because the more tokens you send to the model, the more your costs go up. Now, chunk utilization measures within a chunk how much of it was actually used by the model. Low utilization means you're including a lot of content in those chunks that wasn't necessary to answer the question. And these two together can be used to optimize both your chunking strategy and your retriever logic. Optimal values for these two means that you're including less irrelevant info to the model, which lowers cost again, but most importantly, gives focus to the model, which as we saw, has shown to increase quality. Now, without further ado, let's put all of this to practice. Let's say that I'm a developer at a CPG company, a beauty products company, and I'm building a Q&A chatbot that helps answer questions about my products. Now, I've built my system. I've already built it. It uses Pinecone, of course, as my vector store, OpenAI as my model, and LangChain to execute all the codes. And before putting it in production, I want to, one, evaluate it, but also two, see if I can improve things further. Now let's jump over to my code and first look at how I set up my vector store. So I was given this data set with all my products and a description for each product. And so what I'm going to do is I'm going to chunk this data set and store it on a Pinecone database. So first I read it. Then I define some of the variables that I might want to play with during chunking. And then I chunk it. And so what I'm using here is a recursive character text splitter, which takes my documents and chunks them in chunks of size 400, actually 100, sorry, with an overlap of 50. Now I'm going to use OpenAI's embeddings, the text embedding 3 small model to embed my chunks into the vector store. I define the name of my index, and then I create the chunks and I add the product name to each chunk. I prepend it so that when the similarity when the embedding is calculated, the product name shows up and I can use it for semantic similarity. Now this is what my chunks look like. After chunking, I have the product name and part of that description. And the last thing I have to do is I just instantiate a Pinecone client and I create my index and I populate it. After this, I can check that things went well by just getting some stats, looking at how many vectors are there, and doing a simple similarity search on my vector store. So this was all the setup needed for that vector store. The other part of this is that application part. I already built my chain, which simply calls that vector store that I just built, retrieves a number of chunks or documents, concatenates them, and passes them to an OpenAI model through this prompt that says, answer the question based only on the provided context. I pass the context and the question that I got from the user. Now, and this is where I put all of this together. Now, I might want to experiment with a few different params, so I wrap this whole thing in a function that takes some of these params as inputs. And finally, let's look at how we can do an eval. Now, I've to start my evaluation, the first thing that I have to do is I collect a number of questions that I believe are representative of what my users are going to ask my application. So I have this data set of about 100 questions, or actually exactly 100 questions, that I think are going to be similar to what my users might ask me. So I just read this file, and then I log into Galileo. Prompt quality is Galileo's Python library. I log in, I define some of the variables for my experiment. Again, we're gonna use a chunk size of 100 first. We're using OpenAI's text embedding 3 small model. We're gonna use a top K of 8 to start with, and 3.5 turbo as our chat model. Now, since I want to experiment with a few things and try a few things, I'm going to create some tags that get added to my runs so that I can keep track of what it was that I tried on each run, so that when I identify the best one, I can see what those parameters were. Now, the next thing I do is I define the metrics that I want to use to evaluate my run. This is a RAG application, so of course, I care about my context adherence and completeness, like we said, and attribution and utilization. Now, there's a few other things that I also may care about, like latency, PII, toxicity, and tone. And if you had your own business metrics, you could add them at this stage as well. Now, I simply get a pointer, basically, to that chain that we built using these parameters. I define my project name and my write name for Galileo. And finally, all I have to do is I define a prompt callback, which takes the run name and the project name as inputs, as well as the metrics and the tags that we defined. And I run my chain through all the questions from my eval data set with that callback set. Now at the end, I just call .finish on my callback, and all my runs get logged to Galileo for me to visualize and analyze them. At the end, when everything executes, I get a link that takes me to my Galileo console, which would be here. Now, the first thing that I see at the top are a summary of my runs quality. Now I see that adherence, which as I call it, it's kind of my precision metric, is 0.792, which is good, but not great, and maybe we can make it better. Completeness on the other side is close to 0.9, which I think is pretty good. And utilization and attribution look pretty low as well. Now, right underneath, we see all the questions that were asked in my eval data set and how the application responded. And what I would do is I would go into some of the ones that are problematic to try and find patterns and debug them. So it looks like the first one has low adherence. Let's click on it and see why that happened. Now, as you can see on the left, we can visualize and trace all the steps that we're taking as part of the application, and what was the input and output of each step. Now, it looks like the question was, what are the key ingredients in purifying nourisher? I don't know what that is, but it looks like the answer was the key ingredients in nourisher are aloe vera. And if we go into the LLM step, we see what the model was prompted with, our instruction, the context, and the question. And the response was what we just saw. Now, adherence looks low. And if we hover over, we can see why our GPT judges thought the model was not adhering to the context. And here it looks like, even though the context does mention aloe vera, it doesn't say that it's the only or the key ingredient. And if we go into our retriever node, we can see all the chunks that were retrieved, which ones the model actually used or attributed to. So only chunk 2, it looks like. And we can actually see that, sure enough, the chunk does mention aloe vera, but it doesn't say that it's the only or key ingredient. Now, another thing I'm noticing is that my chunks are pretty short. Sentences are often split halfway through, and it's, if I was a human and if I was the model and I had to make sense of this context, it might be pretty hard for me to do so. So one thing I might try is go back to my experiment and try a larger chunk size. So I could go here and change my chunk size to say 400, rerun the whole thing, create another vector database, another index, and then rerun this with, again, chunk size 400. That would create another run within the same Galileo project. That would be this one. Now, right away, we can see that our context adherence went up from 7.79 something to 0.833, a 4% bump, which I think is pretty good. And we actually see that that first one, that first hallucination or low context adherence is fixed. Now that the chunks are longer, that first result actually includes all the key ingredients in purifying nourisher. And we could probably find a few other instances that were bad in the first one and got better here. Now, another thing I'm noticing is that attribution looks pretty low. Most of the time, only 1 in 8 chunks were actually used. And if we see our average attribution, it's about 0.16, which I guess is about 1 in 8. So one thing I might experiment with is I could either change the similarity score to increase it, or play with my top K parameter. We started with 8, but let's see if we can, if by making it 4, things improve. Now, I could rerun the whole pipeline again, and it would take me to this run. Now, if you remember, we just had adherence of 0.833, and by changing our top K, we not only see that our adherence or that our attribution got better, actually like almost doubled, but our quality also increased. And if you remember, this is because more context doesn't always equal better results. And if we go back to our project, we can see all our runs here and how they differ in our metrics. And again, you can see that we went from a 0.792 in quality or in context adherence all the way to 0.8, almost 5. Our completeness actually also went up, and our attribution increased in that last run. And our cost also, by changing the top K from 8 to 4, decreased by half, just because we're passing less context to the model. Now, in a few simple steps, we were able to evaluate and improve our RAG system. If I had more time, I might try different programs, different embedding models, maybe other retrieval or chunking strategies. And I would also probably look at other metrics. If I repeat this exercise a few times, and once I'm happy with the results, I would put my application in production. And we didn't get to show it to you today, but once you put it in production, Galileo Observe can help you monitor your application there. And you can use those same metrics that you use during your evaluation process to assert that the behavior of your application in the real world meets your expectations. All right, I think that concludes our presentation for today. Thank you all for listening, and we'll be happy to take any questions you might have.
Awesome stuff. Thanks, Kike.
Kike and Rui, looks like we have a lot of questions in our Q&A. If you don't mind opening up the Q&A feature, we can start answering some of these live.
So maybe I can do some filtering for you guys. Just looking through upvotes, one of the questions was a 3-part question, but the first question is, how do you ensure that content gets prioritized? Fetching from multiple retrievers or multiple indexes from the same retriever. Roy or Kike, I don't know if you have a perspective on that.
Well, if you're retrieving from multiple indices, it's probably going to be potentially some form of post re-ranking, right? After the fact. Another way to look at things is if you have like a single index, for example, there's the factor of a top K and some similarity score that comes into play, where you decide like how to cut the set of responses that are actually going to make it into the response. First you decide like how many are plausible answers, and then you decide like what is the minimal similarity score that you want to give that would reflect actual relevance, and that's going to be dependent on your data. So there's no hard and fast rule of what exactly that similarity score needs to be in order for relevancy to actually come out. But besides that, right, like it's going to have to be some sort of internal re-ranking mechanism, right? Because it really depends on like your actual situation, like what is the actual importance of each one of the sources that you're going to use. Like, is one of them more reliable than the other? Is one of them more important in terms of your business problem than the other? So it would really depend.
All right. The other part is, are there any best practices in terms of handling response time? Are you adding more logic to the middle tier? Anything you can, any strategies for ultimately improving response time of the system overall?
Well, in my experience, the majority of the time users are going to have to wait is going to be on the LLM to actually produce the response. So the question is like, what is the best way to get to response, like to basically first token response, right, from the LLM? The methodologies here range again from limiting your the search space in the first place. So for example, segmenting your index into namespaces that make sense. That kind of like gives the database a smaller search space to kind of munch through. A second is to use metadata. So if you're able to use metadata filtering to, again, reduce the search space, that will reduce the latency of your queries. And particularly the ways that you use metadata is very important. There are, basically, if you create metadata with fields that have very high cardinality, and then you index those metadata fields, that will basically lengthen the time for execution. So you'll see basically higher latency. And so you want to be very careful about the content that you save in the metadata and the content that you actually index in the metadata. Typically, you would use it to save categorical data, which is obviously like a lot less higher cardinality, and then that will ensure higher efficiency. So these are some of the ways that you can start thinking about optimizing your queries. Yeah. Osman, I think you're muted.
Still muted.
Muted. Nope, you just lost your audio. I think I have the third question though. Oh, disappeared. Just as I was going to answer it.
It was something like, how is Pinecone better? Right?
Can you hear me now?
I mean, yes, we can.
Okay. Yeah, I was going to say there's a ton of questions on comparing Pinecone or Galileo to vendor X, Y, or Z. Maybe to just address all of those at once, maybe if each of us could, Galileo and Pinecone could just mention, why do teams typically choose Pinecone, or why do teams typically choose Galileo? Maybe that's a more efficient way to answer the questions. Roy, maybe if you want to go first.
Sure. Pinecone is built for scale. The thing that we see most from customers is they're starting with typically millions of vectors, but they want to grow, and to do that without any kind of basically interruption, having to migrate, having to change their infrastructure in any way. And that's exactly where Pinecone serverless shines, right? It's fully capable of dealing with smaller number of vectors for a very, very low cost, but it basically scales up sublinearly in terms of cost when you grow up to the hundreds of millions and billions of vectors. And theoretically, there's no upper bound because we're reliant on the blob store. And so the real question, it becomes the question of cost. And like I said, because in general, again, given some conditions of segmenting the data in a reasonable way, the database scales sublinearly in terms of cost. And that's a huge benefit that makes it viable for very, very large use cases.
And Galileo, I would say there's three things that differentiate us from our competitors. One is we help users across the development cycle. Today we spoke a lot about evaluation and like the pre-production phase, but when you put things in production, we have products that help you observe and monitor things there. And we actually have stuff for if you're fine-tuning as well, we help you fine-tune your models. The second thing is we're platform agnostic. We spoke about Pinecone and LangChain today, but we work with any vector data store, any like with LangChain, without LangChain, any model, and actually any programming language. So most of our users use Python, but if you're using JavaScript, Java, you name it, you can use Galileo. And the third thing is our focus on metrics and our research. Most of our team is focused on guardrail metrics and on building those evaluation metrics, which just a year ago, nothing existed. There was no way to like really assess the quality of a response because we were used to predictive ML where there's a right or wrong answer. And so we've spent a lot of time in the past year and a half, 2 years, researching this stuff and building really high caliber metrics that help users evaluate their systems.
Another question that came up, do we support raw REST API and self-hosting? Kike, I think that's for you.
Yeah, we do.
Great.
In fact, most of our users self-host.
One question that came up is the context window the sole factor behind hallucinations in large language models? That's a pretty pointed question for this webinar. So maybe Roy, if you want to tackle that one.
Is the context window the sole reason for hallucination? So no, like I said in my opening, LLMs hallucinate by definition, right? Like that's all they do, right? Regardless of the context window, right? So like the context window is just a way of saying what's the prompt, and basically what's the size of the permitted prompt that can go into the LLM. But the function, right, that you're calling when you're calling an LLM is basically give me the next token, give me the next token, give me the next token, right? And that is completely, it has nothing to do with the context token, with the context window, right? If you gave it no prompt whatsoever and you just asked it for the next token, it will just give you the next token, right? Like the most likely thing that it wants to give you, even if your context window has one token in it, right? So it really doesn't have anything to do with it whatsoever. The point that you can leverage the context window is helpful because it allows you, as we said before, to steer those hallucinations in a way that is beneficial to you. And usually what it means is you're basically making it so that the LLM, instead of behaving as the source of truth, it knows that it's not the source of truth, but it regards the content that resides within that context, the context window, as the source of truth. And you're using prompt engineering to force it to regard it as such and to build its responses based on that context window. I hope that answers the question.
Kike, there have been a handful of questions asking a little bit about the inner workings, if you will, of the metrics that you went through, context adherence, chunk utilization, etc. Maybe would you be able to share a little bit more about that?
Yeah, happy to. But today, the way those 4 metrics work is they use what we call chain poll. It's actually a research paper that we published a few months ago. So if someone from the team can paste the link, that'd be great. But in short, what that means is that we use chain of thought prompting combined with majority voting. So we prompt a number of LLMs the question of, is this context, like, is the response adhering to the context? Reason, and then give us a yes or no answer a few times, and we combine the answer in a single value. Now, that's how it's working today, and we're actually working on our own models to do these things that we're launching in the next few weeks that are going to use some super interesting version of NLI to compute the same 4 metrics.
One question that has come up in a variety of ways, but essentially, what measures do, I guess, both Pinecone and Galileo take to highlight when a retrieval is quote unquote poor? I think the obvious answer here is, hey, we have evaluation metrics that we've kind of reviewed during this webinar that highlight when various attributes, whether it's the context, whether it's the chunking of the of your context, that are areas for opportunity. Roy, I do know with kind of Canopy and some of Pinecone's latest serverless releases, you folks also have some level of evaluation capabilities in your platform. Wanted to open the floor if there's anything there that you want to highlight that Pinecone does to highlight poor retrieval or retrieval improvement opportunities.
Yeah, we don't yet quite tackle evaluation within Canopy yet. But of course, there's like I mentioned before, there's the similarity score, which is not necessarily an evaluation, but rather an indication on whether on how similar one vector is to the next. It's not, again, it's not an evaluation in terms of good or poor, because sometimes you might be looking for dissimilar vectors, right? Not just similar vectors, right? So it's completely subjective. So this is a long way to say there is not an evaluation method built into Canopy yet, but that's definitely something that we're very interested in actively looking at.
Then I guess a last question, because we are enterprise-oriented brands here, but nothing better than an RBAC question. But has anybody, where'd it go? Has anybody implemented RBAC control or other access control mechanisms within the retrieval? So basically access rights inside the retrieval mechanism. Roy, I think this one might be for you.
Yeah, different companies do it in different ways, but it happens outside of the scope of Pinecone directly. So we do not have RBAC support yet, but I know that it is also a very highly sought after enterprise feature.
Great. There are 60 other open questions, which I do not think we'll be able to get to today. What we will do is, for those of you who have asked the question under your name, we will try to follow up over email. And as always, there's our documentation site. Pinecone has plenty of excellent learning resources as well. I know is helpful for me as I got into this industry. So thanks, Pinecone team. And if there are questions that we can follow up on, we will. Otherwise, it looks like the AI bots are providing summaries as well from their notes. So no better way to end this webinar. Thank you everyone for joining. As always, feel free to reach out through our respective websites with questions. Join us on March 13th for our event, Productionize 2024. Otherwise, stay tuned. We'll be having a webinar with deep learning next week. Thank you so much.
Thanks, everybody.
Thank you, everyone.